Science Journal for Kids and Teens presents How Does Climate Change Impact Satellites? Read by Miranda Wilson. Abstract. There are a lot of satellites in low Earth orbit. We use them for things like communication and weather forecasting. Climate change is actually cooling this region of our atmosphere. This changes the density of air there. Changes in climate could impact these satellites. We wanted to know how much. We used a model to estimate air density changes in low Earth orbit in the future. Then, we calculated how many satellites the region could safely hold. We did this for 3 climate change scenarios. We found that by 2100, climate change could reduce the number of satellites low Earth orbit can hold by 50 to 66%. This means we need to develop strategies to make low Earth orbit a more sustainable resource for the future. Introduction. What do you think of when you hear the term climate change? You probably think about global warming and greenhouse gases, but I bet you didn't think about satellites in space. Satellites help us with things like communication, weather forecasting, and navigation. A lot of satellites, as well as the International Space Station, orbit in the thermosphere and exosphere. These are the uppermost layers of our atmosphere. Together, this region is called low Earth orbit, and these parts of the atmosphere are impacted by climate change. Scientists know that climate change is cooling down the thermosphere. Greenhouse gases increase in all parts of the atmosphere because of climate change. Greenhouse gas molecules absorb heat from the sun. They also give off heat energy. Close to the Earth, this heat is trapped by other molecules. In the upper atmosphere, where there are a lot fewer molecules, heat is lost to space. This means that the upper atmosphere gets colder because of climate change. This changes the density of air and causes the thermosphere to shrink. When the thermosphere gets thinner, an orbiting satellite will stay at the same altitude, but the air it is moving through is then less dense. There is still enough air for a satellite to interact with and create drag, though. This will cause the satellite to lose energy and eventually fall to Earth, which is sometimes a good thing. If the air is less dense, then drag will also be less. Satellites could stay in orbit for longer, and this could become a problem in the future. Currently, the recommendation is for satellites to come out of orbit within 5 years of finishing their missions. Satellites can actively or passively lose energy and fall to Earth, but we keep adding more and more satellites into low Earth orbit. Unfortunately, there's also a lot of space debris in this region. It is from satellites that ran into each other in the past and didn't fall to Earth. Enough collisions could start a chain reaction and create a lot more debris. Scientists call this possibility the Kessler syndrome. If it happened, it would be hard to put any more satellites into low Earth orbit. We wanted to know how many satellites could be in orbit without triggering the Kessler syndrome. This number represents the carrying capacity of low Earth orbit. We also wanted to know how future climate change will impact this number. Here in Figure 1, you can see the number of tracked objects, including satellites, abandoned rockets, and space debris, at various altitudes or layers of the atmosphere. On the x-axis, you can see the year from before 1970 to 2023. On the left axis, you can see the altitude in kilometers above Earth. On the right y-axis, you can see the approximate altitude of the different layers of the atmosphere. Starting closest to the surface of the Earth, they are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The intensity of blue color represents the number of tracked objects, with darker shades representing larger numbers of objects. Methods. We modeled changes in thermosphere density until 2100. We used models from the National Center for Atmospheric Research and the U.S. Naval Research Laboratory. We did this for 3 different climate scenarios. These were from the International Panel on Climate Change, the IPCC. Then, we used this information to help develop our own model. We calculated the satellite carrying capacity of low Earth orbit. We call this value the instantaneous Kessler capacity. We calculated this for our 3 climate scenarios until 2100. Then we compared them to a baseline estimate from greenhouse gas values in the year 2000. Results. We found that thermosphere density decreased at higher altitudes during solar minimums. There's a natural 11-year cycle of solar activity that impacts the thermosphere, and under more severe climate change scenarios. We found that the baseline instantaneous Kessler capacity was 34 to 72 million satellites. The instantaneous Kessler capacity was less during solar minimums. It was also less during more severe climate scenarios. By 2100, we could see a 50 to 66% overall reduction in capacity between 200 and 400 kilometers. At 400 to 1,000 kilometers, this overall reduction jumps to 60 to 82%. Most, 98 to 99% of this capacity is available at lower altitudes. Here in Figure 2, you can see the instantaneous Kessler capacity over time under 4 different climate scenarios. This shows the number of satellites that low Earth orbit can safely hold without triggering the Kessler syndrome. The instantaneous Kessler capacity changes naturally with solar activity. Solar maximums are indicated by vertical grid lines. On the x-axis, you can see the year between 2024 and 2100. On the y-axis is the instantaneous Kessler capacity, or the number of satellites in millions. The different lines represent climate scenarios of greenhouse gas levels by 2100. The baseline, or levels from 2000, can be seen as a black dotted line. Ideal, or limited change, can be seen in blue. Average, or an increase of 50%, can be seen in orange. And severe, an increase in 250%, can be seen in red. Looking at the graph, which of the climate scenarios results in the smallest instantaneous Kessler capacity for low Earth orbit? When and under what conditions? Discussion. Our research shows that we need to think about our sustainable use of low Earth orbit. Climate change will decrease the density of the thermosphere over time. This reduces drag on satellites and will allow them to stay in orbit for longer. And the longer they stay in orbit, the greater the chance for a chain reaction of collisions. In the future, it will be more dangerous to put new satellites into low Earth orbit. Our data show that we have room in low Earth orbit for millions of satellites, but there are some things to consider. 1. Climate change will reduce the number of satellites we can fit into low Earth orbit. 2. The vast majority of capacity for satellites will be at lower altitudes. Space debris falls to Earth quickly from this region because of drag. In our model, this means that lots of collisions can happen and not trigger the Kessler syndrome. But satellites are expensive and have decades-long lifespans. Not many people would want to put satellites at these altitudes if the chance of collision were high. And 3, solar activity naturally changes the carrying capacity of low Earth orbit. At solar minimums, low Earth orbit can't hold as many satellites safely. Any sustainability plans need to consider the 11-year solar cycle. There are lots of things that we can actively do to increase the carrying capacity of low Earth orbit. We can require that new satellites have technology to avoid collisions. We can also put in place space debris removal projects. Many governments track satellites and space debris. Improved tracking and coordination between governments could reduce collisions. Conclusion. Climate change has the potential to impact many things in our world, and satellites in low Earth orbit are really far away from your daily life. But imagine if all those satellites ran into each other. You wouldn't be able to get directions on your phone or watch your favorite TV show. And it would get worse. Planes wouldn't be able to fly safely, we wouldn't be able to predict the weather, and international communication would be limited. So what can you do? The biggest thing you can do is limit your production of greenhouse gases. This means reducing how much energy you use and how much stuff you buy, which takes resources to produce. For example, avoid buying unnecessary items or see if you can get things secondhand. Also, take public transportation, ride your bike, or carpool whenever you can. You can also write to your representatives about investing in green energy solutions and regulating local impacts on climate change. Every voice counts. Thank you for listening to this recording. This work has been adapted from the original peer-reviewed paper in the journal Nature Sustainability, published on March 10, 2025. Research conducted by William E. Parker and others from the Massachusetts Institute of Technology in the U.S. See the full list of authors and their affiliations in the accompanying PDF. Please visit our website, sciencejournalforkids.org, for more free science teaching resources. Hey everyone, we're a small nonprofit and all of our resources are free. So if you like what you see, please subscribe and share.